All right, first two lessons we looked at dealt with arithmetic sequences and arithmetic series. And each one dealt with a common difference. Today we're going to look at the geometric sequences. And a geometric sequence is very similar, the difference being you're going up by a common ratio now. So to go from term 1 to term 2 or term 2 to term 3, you have to go by multiplying by the same ratio to get to the next term in the actual sequence. So not very difficult. If I ever want to find out what the common ratio is, the common ratio can be found by taking, let's say, t3 divided by t2, or t to the n divided by t to the n minus 1. So in other words, what that means is I take any term and I divide it by the previous term in order to get the common ratio. In any geometric sequence, to calculate any term, I use the following. T to the n is equal to t to the 1 times r to the n minus 1. Now, if I start with this value here, all right, I'm going to multiply by a common ratio to get to the next value. The reason it's n minus 1 is because it always takes it back 1 to find it. So for example, if this was a 2 here, so t to the 2, to get my second term, I take my first term and I times it by r to the 1, 2 subtract 1. Well, that should make sense. All right, I'm going to multiply it by 1r to get to that. To get to the third term, I'm going to multiply it by r squared, because I times this by r, and then I times this by r squared to get to the next one, or times the original term, term 1 by r squared. Okay? All right, so this part of it is fairly straightforward. Andrew and David organized on page 23. Andrew and David organized a tree planting challenge. They have people plant a tree and then sign up 3 more people to join the challenge. Andrew and David are the first to join the challenge, each planting 1 tree and each signing up 3 more people. So state the values of T1 and R for the geometric sequence that represents this situation, and state the geometric sequence. Okay, so the initial planters are Andrew and David. Therefore, my t to the 1 is 2. All right, so since they each sign up 3 other people, I have 6 now, right? And then I go from 6, so I determine the ratio. So what's the ratio? Well, I divide by 3. Okay? So the next one is, so T2 is that. T3 would be 18. T to the 4 is 54. T to the 5 would be 162. Okay? So it says state the first T1 and R, which we did. Determine the general term that relates to it. Okay, so the general term, T to the n. What are the 2 things that I'm going to need in order to solve for the general term? I need T to the 1 and I need R. So my T to the 1 in this case is 2. My R is 3 to the n minus 1. Okay? Now, the biggest thing that you need to understand is working with exponents like this. You do not, at any time, times these 2 together and then put it to that exponent. Okay? Now, the reason for that is, I'm just going to go on a little tangent here from what we're doing. If I have 2 times 3 squared, 2 times 3 squared is equal to 2 times 9, which is 18. All right, and that's correct because I'm going to do the squared value first, times it by that. That will not give you the same answer as this. So do not multiply this by this base here and then square it. You can't do that. Exponent law says you cannot do that. If this was a 3, then I'd add the exponents together to get it. So it'd be 3 to the power of 3, but it's not. Okay, so make sure that when you're doing these, that this is the correct way to do it. All right, take a look at the second example on page 23. A company stores 5 kg of radioactive material. After 1 year, 92% of the radioactive material remains. How much radioactive material will be left after 10 years? Okay, so the first thing that we need to do is find t to the 1. So in this case, t to the 1 is 5. How do I get t to the 2? Well, after 1 year, I'm going to have only 92% of that, right? So I'm going to multiply by 0.92. Okay? And then it wants us to calculate what t to the 10 is. Well, t to the 10 is equal to 5 times 0.92 to the n minus 1, which is 9. So punching that into our calculator, 5 times 0.92 hat 9 equals 2.361. Again, let's use 3 decimal places whether the book says it or not. So we get 2.361. Okay. Easy. Not too bad. Straightforward. How does it get more difficult? Well, here's what it's going to do then. So this is just like the last lesson. Last 2 lessons, in fact. All right? They're going to give you the 5th term. The 5th term of the sequence, t to the 5 is 1,050. The 7th term of the sequence, t to the 7 is equal to 26,250. Now I'm going to show you the little bit longer way, but it's more consistent with what we've already done before. So that is this. Let's write this out with the general term. 26,250 is equal to t to the 1, which I don't know what t to the 1 is. And I don't know what my r is, but I know it's to the power of 6 because it's n minus 1. Then I'm going to go 1,050 equals t to the 1 times r to the 4. And now, because in the first lesson I was subtracting or adding to get from one to the other, now I'm multiplying. I'm going to divide this right here. So I'm going to take 26,250 divided by 1,050. That gives me 25. T to the 1 divided by t to the 1 is 1. R to the 6 divided by r to the 4th. Exponent rule says I subtract those exponents. I get r squared. R is equal to 5. Now I'm going to use 1,050 equals t to the 1, 5 to the power of 4, and I'm going to solve for t to the 1. So I'm going to take 1,050 divided by 5 exponent 4. Well, I got something wrong here. What did I do wrong? That didn't work out. Oh yeah, it did. Plus minus 5. So yeah, so I end up with t to the 1 is 1.68. Okay? Now, I do have one thing that I missed. And that is this. When I take the square root, which I've done right here, the square root of r squared and the square root of 25, I can have a plus minus 5 ratio. All right? I can multiply to go from one term to the next by multiplying by a negative r as well. So I have to take that into account. So now I would have to, if I was writing out the first 3 terms, I'd have to do the first 3 terms Number 1, I'd have to do them with the positive r, and then number 2 is I'd have to do it with a negative r. Okay? Now I said to you this is the more consistent way of finding this with what you did with the solving equations in sequence and the arithmetic series or sequences. But there is an actual, maybe a easier way to solve this question. And it's simply this. The fifth term of this equation is 1,050. I don't know what the sixth term was, but I do know what the seventh term was. Right? So what I said earlier is if I want to find the common ratio, I take one term and I divide it by the term before it. And it should equal if it's consistent. So I'm going to take 26,250 and I divide it by x. And that's got to equal the same ratio between x and 1,050. Okay? I'll make sure I got that right. Something doesn't seem right here, but it is. Okay? So x, I multiply that up to here, multiply that up to there. Seems like it's going to be a little bit high. What did I do wrong here? Should be dividing these somehow. Fifth term, 1,050. Seventh term, 26,250. Man, I got an error. This should have worked. Why is it not working? That's going to be multiplied. That's not going to work. I need 26,250 divided by 1,050. 25, and this is multiplied. To get my ratio. Alright, how about we scrap this for a second? I'll come back to that when I get back on the Thursday. Because there is a way to do it that way, but I'm not sure why it didn't work. I'll have to check it. Alright, I'm not going to go through example 4. I will come back to that when I get back. But that'll give you enough work to do. So what I'm looking for Thursday is you need to be done 1 and 2 and probably started on 1.3 for Thursday's class. Okay? If you have any questions, ask Mrs. Davis.